Hi everyone, welcome back to another Calculus 12 video. We're doing 2.4 today, which is the product rule. So I've color-coded it so you can clearly see what's going on here, but if we have two functions that we're multiplying together, then to find the derivative of them, we would do f prime times g plus g prime times f. So it's a nice, easy way for us to be able to take the derivative of some of the more complicated equations that we're working with. So in this first one, it's asking us to differentiate this function here. So I guess the first step in order to make sense of this, what I like to do is basically label them first. So we're going to call this one f, and I'm going to call this one g. So I really do think that a lot of this comes down to organization in order to be able to apply this and to simplify it and to keep track of things. So I think also it's going to make it easier is if we start to look at ways of converting these into exponents instead of radicals. That's going to make things easier for us to work with. So this is like saying x to the 1/2 plus 1. And in this one, this is like saying x to the 1/3. So remember, this always becomes the denominator in our fractional exponent plus just the 5x that we had. I'm going to make that smaller so that we can work with this. So again, in order to work with this and to make it a little bit easier to manage, well, I'm going to call that one our f of x. So then maybe what I want to do to start off with is then find what my f prime of x is going to be. So I'm not even putting anything together yet. I'm not applying this equation yet. I'm just basically setting up the groundwork, and I'm going to organize things to make it easier for us to work with. I would suggest that you do the same type of thing. So my f prime of x, if I look at this, would be 1/2 x, and this would be like 1/2 minus 1, or minus 2/2 is a better way to put it. So I'd get negative 1/2 at the top. So this is basically by us applying the rules that we learned last day. And we know that when we have a constant there, we get 0 when we take the derivative of that. So that gives us our f prime of x. And then if this function here is my g of x, then I would have this as my g of x, and this here, if I'm taking the derivative of this, I would get 1/3 x of 1/3 minus 1, so minus 3/3. So do you see that? I'm going to get rid of that because it's not really there. When I subtract that, I'd get minus 2/3. And then this time for my second term here, if I have plus 5x, when I take the derivative of this, I would just end up with a constant, which is plus 5. So this here is my g prime of x. And this here would have been my g of x. And I'm going to redo that to just make it a little bit cleaner and nicer to work with. So I'm going to get rid of those so that it's easier to see. And now that we've basically separated them and sort of set up the groundwork, we are going to take this and apply that formula to it. So I'm going to shrink it down so we can sort of see everything and make sense of how to work our way through this. So what we would end up getting when we're finding the derivative of this is that we would get, sorry, this is missing an fg prime here. That should be there, which makes it a little bit easier to make sense of because we're taking the derivative of the whole thing. So let's start to apply this stuff that we saw up here. I want to take my f prime. So I want to take this part, and I want to start by writing that one first. So I have 1/2 x to the negative 1/2. Okay. Beside that, I would have just my function g of x. And my g of x is just this one that I had here. So x to the 1/3 plus 5x. And then I'm going to add to it my g prime. So that would be this one here, this one here. So I'm going to do 1/3 x to the -2/3 plus 5. And I'm going to multiply that by just my regular function, f of x, which is this one over here. So that would be times x to the 1/2, all plus 1, like this. Okay, so what I end up getting when I work my way through this is, well, a better way of us cleaning this up and writing this, because we don't really like to write it like this, is I would want to clean this up to say this is 1/2, and this ends up giving us root x at the bottom. So that is the same thing as this. And then I would want to rewrite this to say, I want to make this a little bit thicker so we can see it better. I would say this is 1 over the cube root of x plus 5x, plus rewriting this in a form that's nice and easy for us to work with would be 1 over 3 cube root of x squared times this part here we're going to rewrite. It's going to be root x plus 1. Now, there's a lot of things going on here. I would be okay with you leaving it in this form. So, this is how I would give the overall answer. I'm just interested in you being able to figure out the different parts, the original functions f of x and g of x, and then f prime of x and g prime of x, and applying it to this formula that we have here. Okay, so your work for this would be, I'm going to write it up here, page 92, numbers 1 to 6 all. I'm going to get you to work on those, and that's it for this section.